So let's say you found a skeleton. How would you tell it's a dinosaur? You personally, how would you decide?
Well, interesting question. I don't know. I'd have to do some research on that.
All right, welcome to episode 2 of Landon with Lisle. We are here. This is in lieu this week of Kent with Bent, and next week it looks like we're going to do an Eric with Erica. I don't know if Benthoven will want to show up for that. If he does, that's fine. If he wants to take a break, that's fine too. But that is a different topic. What we are here to talk about now is Jason Lisle, and I have Landon Curtinol with me. Landon, why don't you say hi to everybody?
Oh, good morning, good afternoon, or good evening, depending on your time zone and latitude, from your friendly secular astronomer. And how are you doing there, chat room?
Yeah.
Wave to chat room. And of course, Dapper, it's always a pleasure.
Well, thank you. It is honestly, our conversations are some of my favorite because you always have things that I don't know about to talk about. So, because hey, I don't do all that much space stuff. So.
And I don't do all that much creation museum stuff. So this is new for both of us. But we had a part 1 of this thing where we listened to Lisle and well, I guess how would you summarize it? I'll also summarize myself first. I guess for those who haven't seen the first part.
I guess my summary would be basically universe big. Ooh, God.
I think he spent most of his time saying, "Wow, big, impressive universe, therefore God." Right? The assumption that he's making is because the universe is so big, it had to have God to make it. Right?
Yeah.
This is part of this assumption that when you see something that's amazing, it had to be created, like it had to be a maker creating something, and then there's this fallacy, as opposed to simply saying, with physics you get a universe, right?
Yeah.
With physics, the universe evolves, and you get extraordinary things out of it, based upon fairly fundamental principles, right? There's this assumption that something grand had to be made; it couldn't evolve to get there. And I think and so he spent half of his lecture saying, "Wow, big universe. Okay, God, right?
Right.
And the glory of God is reflected in the universe, therefore God exists." It's this presuppositionalist garbage that sort of says, "Well, I assume there's a God. Now look how big the universe is, therefore the universe proves God," right? It's this circular reasoning. It's or like size intellectual suicide of presupposing God, and therefore everything fits.
Yeah. And one of the questions I had was always okay, so at what state, like what size of the universe is the minimum for you to go, ooh, God? Like if it were 10 billion light years across as far as the visible light universe goes, would that still be ooh, God? What if it were 800 million light years across? Is that still ooh, look how big it is?
Yeah, or really it's just a matter of, you're right, it doesn't really sort of say that, well, because it's this big, therefore it's God, right? There's this, again, he has this kind of assumption that God exists, God is great, universe is great, therefore the universe was created by God, type of thing.
Yeah.
And so far he's not made a scientific argument. He just wowed people with pictures saying, "Wow, universe," right?
Yep.
And if this was the end of his talk, I sit there and say, so what did you really show in that sense?
He showed some pretty pictures, which are admittedly quite nice.
But again, they have nothing to do
right.
with his sort of creationist stance. So hopefully in the second half, we will get over this, wow, the universe is really, really big, and therefore God made it, to something else we can drink about. And by the way, you should mention we have this a drinking convention.
We do have a drinking convention. You're right. I don't know how I managed to stop with that. So, by the way, let's let everyone know what you are drinking, because there was a vote on it today.
Yes, I believe the winner of the poll was a larceny Kentucky straight bourbon whiskey here. And I will point out that this whiskey has an E in it.
Oh, hold on. We got to zoom in on you to make sure that we can see that. Oh, look at that.
There's an E there. I just pointed out. I know.
Oh, we had a Godzilla. So one of our drinking conventions is if we hear Godzilla, we take a drink.
Yes. All right. So with Godzilla in mind, so what are the modes at which we take a drink?
So we take a drink if it is far too stupid for us not to.
Okay.
We take a drink whenever the creationist gets something actually right without it simply being that he is quoting someone else.
Okay.
We also take a drink if the creationist tells a joke that just we barely even notice as a joke. It's so unfunny. Which Jason Lisle isn't a huge joker, so it probably won't come up as much as it might with, like, say, Kent or Eric Hovind. But let's see. Wait, like I said, we drink for Godzilla or Mothra. We also will drink for super chats from our Toho Kaiju titled usernames that might show up, like Mothra J Disco or Titanus Godzilla 2020, who also show up in the fan. We also have I believe, Godzilla fan 401 or something like that comes in sometimes. So if any of them super chat, we drink for that, and that's basically it.
So I'll be drinking with my Mickey Mouse glass. So
nice.
Cheers.
Please don't sue me, Disney. All right, here we go. Are you ready to get into some more of this? And now we were just talking about Jason Lisle had just said that we have pictures of galaxies colliding, and is this going to be a problem for creationism? So let's see what he has to say about that.
All right.
People say, well, is that a problem, having galaxies collide like that? Not for us. Actually, even if our galaxy were to collide with another, the stars just would all pass by each other because the distance between the stars is enormous compared to the size of the stars.
Oh, well, first we're going to drink for Godzilla.
All right. Cheers.
And I'm also going to give a drink for him getting something right, because, yeah, galaxy collisions generally don't result in stellar collisions.
That is true. Gas clouds in galaxies having large crush areas collide and create star-forming regions, but stars themselves rarely collide in galactic mergers. Yeah,
and they can cause new stellar formation, right? Bursts of star formation.
Yes. So we'll see a starburst. In active star formations and starburst galaxies typically are galaxies that have absorbed another galaxy. Either merger of equals or absorbing dwarf galaxies that have substantial gas clouds in them.
Right. Now, I actually do think that there is some kind of a problem with the idea that galaxies. Oh goodness! Drink again for Godzilla, I guess.
Yeah, Godzilla is thirsty.
Yeah, or angry. But so the thing that I have a problem is if we look back just a second at the antenna galaxy that he shows, right? Mm-hmm. It would take longer than the supposed 6,000-year-old universe to get two galaxies to get to this point.
Yeah, and that's something that we typically see a problem with in so-called young Earth, young universe models, is that we see processes that take a long time.
Right.
Now, the if you're going to commit intellectual suicide and just say God did it, then you could say, well, God created this universe with all this stuff happening to be in mid evolution, right?
Yeah, he's
what existed.
He basically created the world complete with galaxies that look for all the world like they collided hundreds of millions of years ago and are still colliding just because.
Yeah, he was bored.
Yeah, he thought it might be fun to make the universe look older.
Yeah.
Okay.
And also they say, like, to deceive, the unbelievers, right?
Well, I will say, Answers in Genesis generally doesn't go down that tack, and especially Jason Lisle, because he is actually pretty wary of making God a deceiver, and so that's one of the reasons why he avoids most omphalist arguments. So if he makes an argument at all, which I don't know that he will, he might just say that this process is something that can take place more quickly than we expect. Or that perhaps, yeah, let's see what he says.
Actually, even if our galaxy were to collide with another, the stars just would all pass by each other because the distance between the stars is enormous compared to the size of the stars. The chances of any two colliding are remote. Just all pass right through each other in a
we heard that
sort of dance. We find that galaxies come in clusters. There's an enormous cluster of
galaxies.
He's
just going to pass over
As we got even deeper into space, we find that we see galaxy upon galaxy upon galaxy. All those little specks you see, those little faint, little tiny specks, those are galaxies at distances beyond imagination.
I will point out, this is a Hubble ultra deep field, and there's actually a couple of stars in there.
Yeah, I believe the sort of yellowish thing with the 4 points in the sort of near the center, slightly to the right and down.
Yeah,
I believe that's
you
a
see
star.
The diffraction readings of this is the diffraction lines from the spider that holding the secondary in the Hubble.
Although it is true that the vast majority of the objects in this picture
that is true
are so I'm not going to say that I'm not going to drink because it wasn't right, but it was not so far off that I have a problem with it.
And this is part of the thing, trying to make statements that are cringe free without appearing pedantic. So when I talk about this image, I say that nearly all the objects you see in this image are galaxies.
Yeah.
There are a few foreground stars, and I will point them out. But everything else, galaxy, 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 galaxy. And then I zoom in on stuff and see more show people more galaxies. In this particular field, the ultra deep field, it's about 100,000. It's actually about this thing is about a tenth the angular diameter of the full moon. So the full moon would be 10 times bigger than this area in the sky. So
okay, that's a pretty tiny area.
Lots of galaxies.
Yeah. All right. Well, wait. Hey.
Of course, we'll come back to this. I think we're going to come back to this particular type of image.
Okay.
A little bit later, if I think I know where Lisle's going to be going.
All right. Well, let's see where he's going.
Those are not stars. Those are galaxies with hundreds of billions of stars each. See, friends.
Wait. Actually, the large mature galaxies, 100 billions of stars each. There's lots of dwarf galaxies and proto-galaxies as well in there. In fact, some of the fainter objects aren't at that mass at that level yet. But it's most galaxies. Most of the major galaxies today are like the Milky Way have that stuff. But most galaxies today are not major galaxies; they're dwarf galaxies. So large and small Magellanic clouds that may have dwarf galaxies that may have 100,000 or so stars are actually a majority of the galaxies out today. Our local group has 3 heavyweight galaxies, about 150 dwarf galaxies.
Okay.
And so he's got to be, again, if you got to be pushing facts, you sit there and say most big galaxies have, or most mature galaxies have 100 billion stars or more.
And we have a 199 super chat from Vandalia 1998 who says Jesus was playing with his Quark Lego set as a kid. Yeah, he just wanted to build a colliding galaxy from his Lego kits.
And of course, the question that the super chat, thank you very much for that, should ask is how many different colors were in that Lego kit?
Quantum chromodynamics.
Yes.
Oh, I know.
All right.
Yeah. All right. So yeah, one of the things I noticed about him is that he's in a lot of this. He's like kind of right. It's like I see what his point is, but like he can't quite get the facts straight, and it bugs me because he's supposed to be an astrophysicist.
Yeah, but to be fair, there are a lot of astronomers that oversimplify things.
Yeah.
To the point of them being incorrect. Now, you can't sit there and just try to be all these qualifiers. So again, I would say mature galaxies like our Milky Way and Andromeda have on the order of 100 billion stars.
Right.
Most galaxies are dwarf galaxies that are orbiting these large galaxies in clusters. And the dwarf galaxies have far fewer stars.
Yeah. All right, let's see what else we got.
It's easier to believe, that the universe is just chance if you don't know much about it.
What?
If you don't realize
What?
how amazing it is.
It seems like it's actually rather the opposite. Seems like the more that science has learned about the universe, the less reason there has been to assume extra natural causes for most of it.
And it's just chance. I mean, he's probably not making a probabilistic argument. He's probably using a colloquialism there.
Yeah, what I think he means is unguided, honestly. Like, not guided by any consciousness.
Well, but because the chance of our universe existing is 1.
Yeah, we can't come up with an a priori chance of the universe being here.
Yeah.
Like, how do you even... What variables would you use?
Yeah.
We don't have any...
Or maybe if you're Mr. Intelligent Design, you get a 3, but generally you get a 1.
Oh, Mr. Intelligent Design. He's... Okay, we're not going to get into him, because that's a rabbit hole we cannot go down. If you guys want to go and see who Mr. ID is, look him up. You will not come away any wiser than when you went into it, though, because he is incomprehensible.
Warning, Red Eye has actually read one of his books.
Oh, really?
And enough said.
But he has an experiment, Landon. All right, let's get some more of this.
Yeah.
Just think of the power involved in all of this. I mean, our sun, one really kind of meager star, producing more energy in a second than 1 billion cities use in a year. Now imagine the combined light of 100 billion stars, but that's just one galaxy. And here we have a sample of thousands of galaxies. We estimate there might be 100 billion galaxies in the universe, or more. That's a lot of power.
Okay,
Spoken
now
into
I'll stop. And this is something that many astronomers get wrong as well. We don't know the actual size of the universe. What you should be saying is our visible universe contains at least 100 billion stars.
Or galaxies, I think.
Or a billion galaxies. I'm sorry. At least 100 billion galaxies, right? And depending on your numbers and estimates. And the problem is that some of the dwarf galaxies that are fairly faint and fairly far away, it's harder for us to estimate.
Right. We may not ever
you
be able to detect
you should be
those.
talking about visible universe, not the universe or the multiverse.
Right, because we don't know what we can't observe, and we can't observe those
and again,
things.
you might say, well, are we being a little bit, nitpicky? I think, again, one of the problems I see with some of these sort of creationist stuff is they start getting sloppy, and then they allow stuff to go, get quite loose in their logic, and then end up in, untenable and illogical situations.
Yeah. Well, one of the reasons why I think it's reasonable to think that maybe the universe is not bounded, at least by our visible portion, and that there are things outside of it, is just the Copernican principle that Earth is not a privileged observation location. And so if you were to observe the universe from one of these extremely distant places, according to the Copernican principle, what you would expect to see is about the same thing as you would see here. The universe expanding about the same way in every direction, with 100 or so billion galaxies in all those directions.
Yeah.
So if that's the case, that would mean that there is a direction in which there are extra galaxies that we can't see because they're too far away and receding too fast. So the Copernican principle, I think, tends to lead to a much larger universe than the visible universe.
Sure.
But
sure.
I
Again,
guess...
So I'm not trying to be nitpicky, but again, if I were there on a friendly panel, I would say, well, Lisle is actually referring to the visible universe,
right?
The observable universe, and we can't make statements about the unobservable universe yet.
Yeah.
So.
The most we can make is reasonable conjecture, like it probably exists, and it's probably full of similar stuff to what we can see. Probably, but I can't say for sure.
All right, so let's see what happens.
Here we go. Oh wait, maybe Kent Hovind is right, and just outside the observable universe is a giant sphere of water. Not kidding.
Existence by the word of God. That's power. That's not chance. That's not a random chance thing. That requires an incredible power source. It makes sense in light of what the Bible teaches us about the biblical God.
So the idea that it requires an incredible power source seems to be implying that something external to the universe has to be shoving energy into it. But why?
Again, this fallacy that you see something that's intricate and fine detail, therefore it had to be made, right? It's kind of the thing they're going about. As well as you see something bigger than yourself, therefore there must be something bigger than yourself that made it.
Yeah.
And that doesn't logically follow.
Okay.
Right? Again, nothing he said is scientific. He's merely saying we as Bible-believing Christians, he's saying, as a Bible-believing Christian, the big universe is consistent with a big God. That's all he's been saying up till now. He's wasted
15 minutes or so of this audience's life.
Yeah.
But hey, you know what? He's given us something to talk about. So
and it doesn't prove. That's the other thing is all you're doing is preaching to the choir, people who've already believed. It doesn't prove anything. Yeah. And again, I wish he would stop making the statement of, well, what's the random chance that
because
this happened? Because the answer is 1.
Right. Well, and the thing is, it's like, okay, so the structure of the universe, at least post the first moments of expansion, right, is primarily governed by relativity, which is a very non-chance sort of thing. Like, it's not, what's going to happen? It's, drink for Godzilla. Twice, I guess. Or thrice. We could do thrice.
Wow. All right.
So, I just lost my train of thought because of Godzilla. Oh, right. So, relativity is not a very chance-based phenomenon. It's very much in the same realm of sort of the clockwork universe idea that was popular in classical physics before quantum physics really started to put a wrench in that.
Yeah.
And
it really is that when you make the speed of light invariant, you have the only sound mathematical model you can build is something where Lenz's transformation exists, and that gets you into some very interesting non-intuitive situations with all this time dilation and so forth. But the principles, even though relativity is a modern physics concept, the principles are actually quite easy to understand, right?
Right.
And a good book, Relativity Explained, is a really good book on explaining the fundamental basics of relativity. Some of the implications are amazing, but again, this is back to this business of saying, well, doesn't the universe prove the existence of God? No. Out of laws of physics, you get a universe with a certainty of 1 because it's happened here. No probability is required. Sans Edgar.
Yeah. Well, like I said, Edgar is a whole different topic.
Yes.
It really does. And if you think about it, all of this, according to Scripture, was made in 6 days. Most of this was made in 1 day, wasn't it? Day 4. God spends 5 days working the earth, making it right for life. He takes 1 day, day 4, and makes everything else. Isn't that interesting?
Here's again something that's kind of odd. First of all, we're not going to get into a theological discussion. Given that we've had this thing, would people mind if I added in a Copperworks single malt whiskey? I know that we have a Copper fan, and it's a Seattle local area. Would that be okay if I snuck in a Copperworks?
I mean, I don't think it would be a problem, but I'll tell you what. If people in the chat, if you've got a problem with sneaking in a little bit of the other whiskey, which does that have an E in it, Landon? We got to find out about that.
Oh, okay. Here again, and there's a pretty significant. And by the way, you can I think I subscribe to the notion that the spelling is a indication of origin. So Irish and American made of that bitter drink typically does it with an E, although there are exceptions, and vice versa. So
yeah. Oh, and we got a $2 super chat from Benthoven, no relation. Adding copper is the best idea ever. There you go.
Yes, and I do want to recommend, if you're in Seattle, to go to it's down the the Capitol steps next to the harbor in Seattle. The Copperworks distillery has a really big facility there with these wonderful copper stills that they brought in from Scotland, and they're beautiful copper things. I highly recommend.
Okay.
Try it and buy something. So, cheers.
Okay. And so one thing that I want to point out about this whole the Earth comes first and then the whole rest of the universe is that there's a reason why there was reluctance initially to accept that anything but the Earth could be the center. And it's because it doesn't make a whole lot of sense to make one little ball of rock going around a star, going around a galaxy, racing through the universe, being orbited by a satellite, all this. And that rock is the first thing you make. And then you make the thing that it's embedded in. And then you make the thing that that's embedded in. And then, you go out, but the thing is, at no point did you actually make, it's sort of like, let's say you want to make a fish tank, right? You don't start with a fish. You start with the glass, and then you add the water, and there's an order. If you want to make a universe, usually you don't start with one tiny fleck of rock. You start with, great big distributions of mass, like galaxies and things like that. So, and I guess I can't say if you make a universe, because when have I made a universe for real? Yeah. But it's not a logical progression. But we got Vandelli 1998 for $1.99 who says, only if you share with the rest of chat. Oh, you got to share your copper distillery. What was it? I can't remember the whole name.
Single Malt Copperworks.
Ah, there we go. So yeah, you got to share it with the rest of the chat.
So, as I say, I think also this notion early on that the universe was this Earth with these shells around it was kind of this reflects in the creation myths that picked up. And by the way, the creation myths in Genesis are not consistent. And so, but those people, the problem with people that take the Bible literally is they run into problems of logic. So
twice, I guess.
Wow. All right, so let's continue on with Mr.
Here
Lisle.
we go. Yeah.
Dr.
I love
Lisle.
the way the Bible.
Yes, he does have an actual PhD from an accredited university in astrophysics.
Yeah, I did not mean any misrepresentation.
Yes, he is legitimately Dr. Lisle.
Describes the creation of all these hundreds of billions of galaxies with hundreds of billions of stars each. It's summed up in this little phrase, he made the stars also. As if it was just so easy for God to make all that.
Oh, was that a joke?
I think so.
All right, I guess we drink for it.
All right. Now, I hope the chat room is going around and drinking as well.
Well, we always say that we don't encourage you to play the drinking game, but you're welcome to, because we accept no liability for any brain damage or property damage or...
It's true. I didn't say what they're drinking. They could be.
Oh, yes. Water. Yes. Please be safe out there.
Because he's God. It's almost like, what would go really good with an Earth? A universe. Let's throw that in too.
Except it's literally the other way around. It's like, what would go good with a universe? A cool little planet with critters on it.
And I must say that in the history of religion and its fight with reality, one of the things that they clung on to for a long time is the Earth-centered universe, right? And so people like Giordano Bruno, one of the first people in Western culture to posit that those dots in the nighttime sky, the couple of dots out there in his image, are actually stars like our sun that have planets around them.
Right.
And he actually even went so far as a theologian to say, and therefore they have their Jesuses and their Bibles and their stuff too, right?
Well, interesting. Take a drink there.
Yeah.
Interestingly, even as late as C.S. Lewis, you get some ideas that there might be essentially alien Christians in the solar system. So he has a sci-fi series in which Venus and Mars are inhabited by various intelligent creatures, and they are apparently aware of Jesus. and are Christians of a sort, at least on Mars. And then Venus is just now having life added to it. So the main character goes and meets the Venusian Eve, who lives on this strange swamp world where the only ground you can walk on is plants that have had their buoyant surfaces come up to the surface of the water. So it's a very interesting take at the sort of the ideas of what might aliens have to do with Christianity and things like that. So, all right, here we go.
Let's put in 100 billion galaxies. That'll really impress the creatures that are made in my image. And that's what it should do. It really should do that. Well, aside from the glory of God, I think we can see the universe clearly declares God's glory. But we also find that the Bible is right when it talks about the basics of astronomy.
Okay.
Things that we take for granted today. But in the past,
like the solid dome.
There was a time when people thought the Bible was wrong about some of these issues.
And it never stopped, and Joshua stopped time, and sun stood still, and the sun went around the earth, and all the things. Yeah.
Well, hey, you know what, Landon? Maybe he's going to show us.
Let's see.
For example, the Bible talks about the spherical nature of the earth.
Oof, except circles aren't spheres.
And it also talks about the flatness of the earth and so forth. So
yeah, I've been pretty consistent that while I don't think the shape of the earth, like teaching you the shape of the earth, is ever the point the Bible is trying to make, it does assume a flat earth, at least in the Old Testament. There's one passage in the New Testament where, Satan shows Jesus the kingdoms of the earth. But I honestly think that is probably not... I don't think the idea is that he's being brought to a mountain tall enough to physically see them. Yeah. And the way I've always seen it interpreted, even in fairly older Christian works, things from like the 3rd and 4th century, the interpretation is that he's showing him a vision up there, and he takes him up to the mountain because it's an impressive, awe-inspiring location.
The four corners type of stuff.
Yeah.
And again, what he's doing really here is he is taking a translation of heavily modified or modified works called the Bible that they determined was canon, and they find any word that could be roughly translated in something roundish, and then say, see, the Bible predicted a spherical earth.
Well, if I remember correctly about these particular verses, the Hebrew at least is fairly clear that it's a circle. But the thing is, Hebrew also has words that you can use for sphere. Like they have a word for a ball or an egg-shaped thing or something like that. So if you wanted to say the Earth was a sphere in ancient Hebrew, it would be trivial to do so.
So I would refer people to the Milwaukee Atheists. They do a lot of studies of biblical text.
Yeah.
And we can move on from there.
Oh, also, I want to point out one thing from the chat. So Thronimulus also said, or I think it was Thronimulus. Oh, no, it was Robert Adset who said 4 corners of a sphere. I do want to point out that the 4 corners thing, as far as I can tell, has never been something that was thought to be a literal aspect. Usually it corresponds to the cardinal directions. And each cardinal direction was assigned a wind and certain anthropomorphic ideas about it.
But this creationist bunch, they typically have to have literally the Bible as translated into English that they can read is literally the word of God, correct, true, blah blah blah. They don't have any of these fuzzy wheel rooms. So analogies, poetry has no place in their literalist camp.
All right, well, here we go.
In Isaiah 40:22, the circle of the earth. In Job 26:10, it says that God inscribes a circle on the face of the waters at the boundary between light and darkness. And that only makes sense on a spherical world. Not just a circular one, but a spherical world.
Do you know what? Is he trying to talk about the Terminator line?
But a boundary doesn't mean that the thing on the one side is a sphere.
Right. If any point source of light will have a point, if it's in some medium that isn't completely transparent to light, we'll have a boundary that's going to be spherical, past which you're not going to see the light. So, yeah, I guess I see where he's going, but it's a pretty stretched interpretation.
That's the only way you can make sense. The Isaiah passage, you might think, well, maybe just a circle, but with the Job passage, there's no doubt it's referring to a spherical planet. And that might have been hard to believe when those verses were written, because they were written in a time when people predominantly thought the world was flat. Maybe a flat disk, but nonetheless flat. In fact, if you consult most secular textbooks, they'll credit Pythagoras with being the first to come up with the idea that the earth might be round. And they usually credit Aristotle with being the first to prove that that is so. But Pythagoras is 500s BC, Aristotle's 300s BC. The Bible got it right a lot earlier than that. Isaiah is 700s BC.
Actually, his thing about Job, we have a particular gentleman who's an expert on Job who will, have comments about that age. But again,
okay.
I refer you to Malky Atheist and other experts.
So one thing
history.
I do want to note about it is he's apparently objecting to the idea that Aristotle proved the roundness of the Earth. But the thing is, even if the Bible were right about the Earth being a sphere, which I'm going to contest that it's actually saying it's a sphere in these verses, the Bible saying it isn't proof.
Yeah,
that's not what proof is. It's
you're
contention.
Deciding the literal interpretation of it to fit something that may embarrass you does not prove that the Bible is correct.
Right. Nor does the Bible being correct, if it were in this case, prove what it's correct about. You still have to actually go and check.
Yeah.
Like if the Bible said that rhinoceroses only had 3 toes, that doesn't make it true. What actually makes it true is when you go and check a rhinoceros.
Job, we think, is around 2000 BC. The earliest book of the Bible to be completed anyway. Moses hadn't yet written Genesis at that point, although some previous documents may have existed.
They're still going with the Mosaic authorship of Genesis, so that puts them in an extremely small camp, even in Christianity.
Well, got it right before the experts of the day, as far as I can tell. By the way, I have to add something here, too.
Oh, and we have a $4.99 super chat from Vandelli1998 who says, my power is out at my house and the cell will die soon, so going to have to watch the rerun. But first I have to say, why does God need a starship? LOL, Star Trek. What does God need with a starship? It's a great line. It's one of the few good things about Star Trek V, because I'm not generally a big fan of Star Trek V. But yeah, that is the greatest part of it. So thank you very much, Vandalia, and I hope your power comes back soon if you can still hear me.
So, some people are under this impression that Columbus was the first to think that the Earth was round, and that he was trying to prove that. That is a myth.
Yep.
People already knew
he got
the world
that
was
right.
round at the time
Drink
of
for that.
Columbus.
Yep.
He just thought it'd be faster to go that way. I just have to dispel that because you hear that from time to time. The Bible teaches that the Earth is suspended in space. In Job 26:7, it says that God hangs the Earth upon nothing. Wonderful poetic description of the nature of gravity, isn't it? And of course, that would have been hard to believe at the time that it was written. Again, Job around 2000.
I think it's not.
So why do you have a poetic interpretation there in Job, but Genesis being literal?
Well, actually, I think here he's saying that might be literal given the language being. I don't know. So my thing on this one is I'm just going to go ahead and say that I don't think that particular statement is something where we can say the Bible definitely got it wrong, but also saying that going from that statement to the theory of universal gravity, like you can draw that line, that's a pretty big stretch. Like, if it were so obvious from the Bible, why did it take so long for people to catch on? So yeah, as a description of gravity, I'm going to have to be like, press X to doubt on that one.
BC, but even as late as 800, 900 BC, the Greek experts thought that the Earth was a flat disk and floated in water. And doesn't that make more sense? Could things float in water? We've seen that. But to hang something upon nothing? What nonsense is that? Might have been hard to believe. But we know that the Bible got it exactly right. We have pictures of the Earth from space today, and it literally hangs upon nothing. It's a great description of it.
No, it figuratively hangs upon nothing.
Right. The Bible, I believe, teaches about the expansion of the universe. It says that God stretches out the heavens as a curtain, spreads them out as a tent to dwell in.
And that's where I'm going to take a drink for it being too stupid.
Yeah.
Because here's the thing. When you take a tent and stretch it out, right? Now we're talking about these sort of Middle Eastern tents, and I'm going to see if I can get an example here. Okay, so yeah, all right. So I'm going to show a picture of a. Oh, that's not quite. There we go. We'll grab this one. So open this here. So Landon, unfortunately, you'll have to check this on their live stream, but unlike the watch link. But this here is a tent built by Bedouins. Now, Bedouins are a group of Arabs that maintain a nomadic lifestyle, and they are one of the few Semitic people to still do so.
The Tuareg in the Sahara Desert also.
Yes, although the Tuareg aren't actually Semitic. They speak a non-Semitic Afro-Asiatic language, if I remember correctly.
Yep.
So there is cultural commonality because there is a language family that is wider than Semitic, which includes the Tuareg. But so this is the kind of tent that we are thinking of when we're thinking of the ancient Near and Middle East Semitic peoples living in the desert. And one of the things that you might notice about it is that it has this shape where it goes all the way down to the bottom, comes up over you, and all the way back down to the bottom on the other side. Just like a solid firmament of the dome of the sky. What this is talking about is God spreading the stars across the dome of this firmament. That's what this is. This is the kind of tent he's thinking about. This tent isn't expanding in all directions infinitely. Because it would be a pretty crappy tent if it did that.
Yeah. By the way, I also mentioned that he's talking about Job. A lot of scholars think that the Book of Job was authored sometime between the 7th and 4th century, where the 6th century BCE is the most likely thing. This notion of a 2,000 years and oldest book thing is
contested, to say the least.
Yes, is not very scholarly.
Well, like I said, this is a group that's maintaining the Mosaic authorship of the Pentateuch, which is, I mean, that hasn't been taken seriously in virtually any Christian or Jewish circles for quite a while.
Even the historicity of Moses is contested. So.
Oh, yes. So here we go.
And I think that's describing the expansion of the universe, either in the past or perhaps even continuing into the present. And that would have been really hard to believe when it was written, because the secular philosophy at the time was that the universe is static and eternal. And that view persisted up even into the 1500s, the idea that the universe is just static and eternal. It wasn't really until the 1920s that the secular astronomers, from observations of galaxies, says, you know what, the universe seems to be expanding. Well, how about that? The Bible got it exactly right.
Then why weren't all the Christians who were astronomers up until this time talking about the expanding universe?
And again, it's one of the things where you take something and you find a synonym of an English word that you then translate a Hebrew or Greek or whatever the origin of the thing is, and then say, see, the Bible says blah. This is this sort of backdating stuff that is right with this sort of so-called apologist, right? If the Bible was that obvious, it wouldn't have to require all these people apologizing for all the stuff that gets wrong.
Now, if you want to, there are parts of the Bible where I say, oh, well, it's actually fairly early to get that kind of a rule in. So, for instance, in the Bible, it says that if you touch a corpse, you have to perform various rituals involving washing your hands and things like that before you are clean again. Well, that's a pretty good precaution. So, if you want to impress me there, you can say, well, here's something that the Bible got right before we knew it was right. And we knew that they got it right because people were talking about doing the thing that it's getting right. People were actually performing these ablution rituals to clean themselves off after touching unclean things like scat and dead bodies and things like that. Okay, fair enough. That's good advice from the Bible that was around before we had anything like germ theory of disease to tell us why it's a good idea. Okay, but this one, in order for you to tell me that this is actually talking about the expanding universe, I need you to find me an astronomer talking about the expanding universe and referencing this passage as why he thinks it's expanding. Till you do that, my interpretation of it, describing the dome of the firmament, is a much better explanation.
Yeah.
And so that's what we call the Hubble Law, the idea that the universe appears to be all stretching out. Now, I have to add something here too, because some people say, well, doesn't that mean there was a Big Bang, right? Because you run it backwards. Doesn't that mean the universe exploded into existence 13 billion years ago since it's expanding? But that's not the case, right? I mean, some of you are expanding a little bit. That doesn't mean you exploded into existence billions of years ago.
Lame joke.
Lame joke. Also, all of them did start out as a tiny single cell, which then
But this notion,
expanded into a person.
The Big Bang is not an explosion.
No, it's not. It's really not. But yeah. So
It's an expansion of space, an expansion of space, but the Big Bang models, don't use the word explosion, right? He's making a joke to deliver a punchline.
Yeah.
Just means you're a little bigger than you used to be. And so it is with the universe. Apparently the universe is a little bigger today than it was when God first created it. But it doesn't mean that it was ever a point, or that God could have created it with size and then stretched it out a little bit. And people said, oh, but the Big Bang predicted this expansion. And so it at least counts as evidence in favor of the Big Bang. But
it didn't predict the expansion, it explained the expansion.
Yes.
The expansion was observed first. So
yes.
I don't know why, and the thing that bugs me is that him getting that right wouldn't hurt his point any. It's like, just get it right.
But it doesn't. Because the expansion was discovered in the 1920s. The
Big
Bang,
he is going to get it
idea
right.
that the universe came from a point was invented in 1931 as an explanation, a secular explanation for this expansion.
All right, you know what? Fair enough. You got that one right. I'll take a drink.
Except the person LeMay that made that explanation was actually a Catholic priest.
Right, who was obviously there to get everyone to stop believing in God.
They probably think that Catholics are worshiping the devil, so...
Well, they tend to, but they tend to also... Well, they tend to be anti-Catholic, but they also tend not to think that Catholics are atheists or pushing atheism. Like, they recognize that Catholics don't have as their goal getting everyone to be an atheist. Because they think that they have a corrupted form of Christianity, but it's clearly not atheism. Like, Catholics believe in a God, they just think that they're wrong about it, and they do it the wrong way.
Yeah.
So...
All right.
Here we go.
So it's not something the Big Bang predicted. The Big Bang came later. It's post-fiction. That's different.
That is, yeah.
Conservation of energy and mass. Something, this is a little more abstract, but I do believe the Bible teaches that the amount of stuff in the universe is constant. And that's what we call the conservation of energy, or the conservation of mass. Einstein tells us energy and mass.
Mass is not conserved energy.
Yeah, well, once we take into account the mass energy equivalence, we can kind of say if we count matter as mass as matter, can't talk. If we count matter as energy, which it is, then we can say energy is conserved. But I think he's actually about to talk about that, so maybe we'll give him a quick chance.
Are basically the same thing, measured in two different ways. We'd expect this from Scripture.
Yeah, okay, yeah. He said mass and energy are the same thing, measured two different ways. So, not how I would have said it, but I'm willing to give it to him.
Yeah.
But I want to see
Because
what this Bible passage
him,
is.
The Bible says, and God ended his work of creation on the seventh day. Genesis 2:2.
Well,
and so we'd expect no new material would come into existence, because either it would mean that God's still creating, which cannot be because he ended his work, or it would mean that something comes into existence apart from God, which cannot be because all things were made by him.
But it doesn't preclude things going out of existence. Like, why couldn't... Like, if all we have to go on are those two passages, we don't already know that the mass energy, or the conservation of energy, is well supported. Let's say we just ignore that. Why couldn't we conclude that the universe may very well lose energy that just kind of disappears? Like, why is...
Hello?
Oh, hello?
Hello?
I can hear you. I can't see you moving, though. Landon?
Uh-oh.
Maybe stop and restart your camera. Oh, okay. I see you again.
We're back again. All right.
Okay, sorry. I guess we lost Landon. I didn't notice because I was talking. Sorry about that, Landon. So what I was saying is, if all we have to go on is these two Bible verses, it doesn't preclude a universe that simply loses energy. So this does not get us to the conservation. It gets us to the first law of thermodynamics. Not even there.
But Lisle is one of these people that rejects
logic
processes in the universe. Like he's known to reject things like star formation, right? He wants the creation, God to be the only thing that created, and everything else is kind of steady state after that.
Right.
Ironically, right? He's pushing, but he's saying, he's taking, science is talking about expanding, space expanding, but he then says stretches, right? But then of course, is he going to go and say, because we found the universe accelerating, that somehow stretching is accelerating, that tent accelerates in its stretching? I mean, at what point are you going to try and wrap?
Oh, I think we cut out again, Landon. Landon, can you hear me?
Yes, I can.
Oh, for a second I couldn't hear you. All right, but yeah, well, let's see what else he has to say. Because actually, we're getting pretty much at the halfway point, and we might end up just starting part 2 and seeing that and going on that for a few minutes.
All right, let's let him go for a while.
Oh, I guess the spacebar isn't going to work for me. There we go.
And these are generalization statements. Of course, I do allow for God to do creative miracles. There's no problem there. But in general, he's not creating today. Creation was finished by the 7th day. So
it's finished except when it's not.
Existence.
Got it.
And we expect material would continue to exist because God upholds all things by the word of his power, and in him or by him all things consist or hold together. So God maintains that which he has created.
But if you get exceptions for your first part, I get exceptions for this part there, Jason.
Yep.
Which means that God can allow things to simply disappear from existence, which means violation of the energy conservation principle.
Yeah. So he's going into this sort of presuppositionalist garbage, where he will say, okay, whatever facts you have, I will try and interpret where it's convenient.
Right.
Passages that imply this stuff. But don't you dare interpret stuff I want to be literal, because there's certain facts that I want to have happen because I'm so afraid of hell. I have to commit intellectual suicide to maintain this mythology.
Yeah. All right, here we go.
How about that? And those two principles together are the conservation of energy and mass. And again, usually James Joule, I think, is credited with the discovery of conservation of energy. At least he's the earliest that I could find, but he's 1800s. The Bible speaks of these principles thousands of years earlier. Isn't that interesting? The Bible talks about countless numbers of stars. It describes Abraham's descendants as the stars of heaven, as the sandwiches upon the seashore, and a metaphor for an uncountable, humanly uncountable number. Of course, God counts the number of stars and calls them all by name, but it's humanly uncountable. And that might have been hard to believe when the passage was written, because you can see...
why isn't he, for example, talking about uncountable in terms of the mathematical sense, right? Why does he pick that definition to backfit his hope that the Bible, written by mostly ignorant savages, has something relevant to say about the current time? And why does he get to pick and choose his stuff, right? Because uncountable to me, I go to the things like Cantor sets and uncountable infinities and so forth. But he's talking about, and again, he's not being precise when he talks, because he's kind of implying the visible universe of known stars.
Right.
It's so but see, it does. You don't have to be that pedantic. You simply say, and in our visible universe, we have observed at least 100 billion galaxies, and perhaps more.
Well, I feel like
it doesn't take much to be more precise without being pedantic.
And I feel like in this passage where God talks about Abraham's descendants being more numerous than the stars. Now, granted, if you live in a big city in modern, like North America or Europe, or if you're in one of the big cities like Perth or Melbourne or something in Australia, something like that, and you look up at the sky, you're probably going to see like maybe 20 stars. But if you're out in the middle of nowhere on a dark night where there are no city lights, like people who at the time that this Genesis was written would have been most of the time, I mean, good luck counting the stars that are out there.
It's about somewhere, depending on what you call visible,
right,
and how good your eyes are. There's somewhere in the 6,000 to 7,000 stars that are bright enough for the human eye to detect them.
Right. And the thing is, if you want to try and count them, you're going to have to keep track of which ones you've already noticed, which is already going to be pretty difficult unless you are doing this a lot. So the thing is, to understand that the stars seem uncountable when you walk outside and look at them, you don't need to assume that they're talking about the galaxies.
And again, he'll say, well, Bill, that didn't mean that they're uncountable stuff. It just means it's a number hard to comprehend, or a lot, right? And so again, he gets to selectively decide when poetry fits his narrative and when it has to be literally factual.
Yeah. All right, we'll see what else we got in here.
A few thousand stars with the naked eye. Countable. Big number, but countable. Until we invented telescopes and we realized, oh, that Milky Way that looks like that just faint band, that's actually hundreds of billions of stars. You couldn't possibly count that. It's a wonderful description. Absolutely wonderful. Now here's my question. Have we learned the lesson of history? In the past, whenever the experts of the day have disagreed with the Bible has always turned out to be right because it's the Word of God.
Except that isn't true. You haven't given us any examples of the Bible being right contra the experts.
The experts definitely disagree with the Noah flood myth.
Well, yeah.
And the evidence shows that the Noah's flood was not a universal flood, if it even had, if it even was a Noah, right? And so, so what he's trying to say is, look, I'm interpreting English translations of words from these books that evolved and became canon based upon some people in certain councils deciding what's true and what's not.
Landon.
And therefore, the Bible is the Word of God, right?
Landon, you brought in my least favorite atheist myth. There was no council that decided the canon.
I said councils that decided.
There were no such councils.
There have been councils that have decided, haven't argued over what's canon and what's not.
No, there haven't. All of the councils dealt with other aspects, and the matter of the canon was actually settled outside of them. The final canon, the final list of the canon was actually sent out.
We're using council and canon in two different ways.
Well, when I say council, I mean a meeting of bishops from either a region or everywhere.
That's not what I'm talking about.
Ah, okay. Well, in Christian history,
people got together to decide what was canon and what was not.
There were groups of people discussing this, but in Christian history, the word council has a fairly formal definition. So,
okay.
Which, granted, that's part of sort of the specialty of learning Christian, specifically Christian religious history. It has its own subdiscipline in history. So, fair enough.
It's not surprising. What about today? Well, some of us have learned a lesson of history, but some people haven't. Because you'll find people today that say, oh, yes, but today we now know the Bible got this wrong and that wrong and the other. And if they state that way, they haven't learned the lesson of history. They haven't learned that God is always right on every subject on which he touches. And one of the areas today that in particular comes to mind is the age of the universe. Because that's one where they say, oh, the Bible certainly got it wrong here.
Ooh.
Well, I want to show you that when you actually look at the evidence, it's consistent with a young universe, a universe that's the age that the Bible indicates. There are many lines of evidence that confirm the universe is thousands of years old. Not 13.7 billion or whatever the big bangers require. Scripture teaches a young universe. The Bible makes it very clear God created in 6 days. In fact, most of the objects we look at in the universe, the luminous objects, certainly were created on day 4. The Bible makes that clear. He made the stars on that day. By the way, the Hebrew word for stars would include things like planets as well. So the luminous objects were made on the...
Oh, we're just going to grab part 2.
The 4th day. And we know that was a few thousand years ago by adding up the genealogies. You know those verses you love to read before you go to bed and so on?
Before we hit phase 2, I am going to do the quick intermission, grab myself a fresh beverage because I have run dry and we can't do a drinking game if I don't have a drink.
All right.
So, all right, I will be back shortly. Everybody, enjoy the music and whatnot. I want to take a moment to talk about something serious. There is a problem facing late surviving non-avian dinosaurs in modern America. Hunting is very strictly regulated, and only allowed at certain times of the year. This means that for much of the year we have to rely on farm-raised food, which means money. If you want to help a starving dinosaur, please consider donating on Patreon, or buying from my merch store. Links are in the description. Please help. Dinosaurs all over YouTube are depending on you to help them through the hunting off-season. All right, we are back. I cut the intermission just a little bit short because both myself and Landon got back before the end of the first segment. So I know the song is fun, but, you know. And Landon had something he wanted to say, but didn't realize we were muted.
Again, it's interesting. In this first part, he was picking poetic interpretations that fit his narrative. But now he's going to go literal on creation myths and creation poetry.
Yeah. Either way, it's going to have to... So that is one of the things that always bugs me, is it's like, you know, you could just port over your willingness to take these things not literally and put them into the parts that are currently in contention. And then suddenly you don't have to say that the Bible is wrong about all this stuff.
And who wants to pick up history teaches? Well, history teaches, has taught us in terms of people literally pushing their scriptures, that they are often wrong when they go and say things like, you know, that the universe is flat, or the earth is a center of the universe, those sorts of things. The sun goes around the earth. These are things that you know, people pushing religion have gotten wrong time and time again. So if history teaches you something about people pushing religious doctrine out of that book, is they're often wrong.
Yeah.
And they push things that don't have evidence, and when it's convenient for them to try to escape that, they'll say, "Oh, well, we're you have to interpret this in a proper spirit." So
right. All right, let's grab a little bit more. Oh no, spacebar still not going to work.
So beget so and so, and they beget so and so. Yeah, you add up those ages, and you find that was a few thousand years ago. The evidence is consistent with that, folks. And let me show you just a few. The excess internal heat of the giant planets. Jupiter gives off twice as much heat, twice as much energy as it receives from the sun. Now, if it's giving off more than it gets, that means it's losing energy, right? And it can do that for 6,000 years, and it's not a problem. But if it's billions of years...
Well, it wouldn't be a problem for 6,000 years, would it?
I mean, it's not 2 to 1, but even so, you know, with the Juno probe, we actually have a much better idea about what's going on inside Jupiter and why. And the physics of Jupiter explains the processes of the energy coming from the Jovian system, and the observations with spacecraft confirm those models with data.
Yeah. In fact, actually,
it's not that Jupiter is cooling down because you get other objects like the moon that have cooled down from their formation time that aren't in that way. So he's cherry picking.
Yeah. Let's see what he has.
It's old. It's a huge problem. Why isn't it run out of energy by now? It's kind of like a potato. You take the potato out of the microwave, it's nice and warm, and it radiates that heat to space. After a while, it cools off. Yes?
Because the energy that's currently heating Jupiter isn't initial energy from the collapse of Jupiter from a more diffuse state. It's not all that potential energy having been turned into thermal energy and now it's hot. It's primarily from nuclear processes. It's the same reason the Earth is still hot.
Yeah.
And
it's the same reason why Io is hot, is because of tidal heating and current passing through it, given its current conditions.
Right. And I have done the some of the math on this, and if you run back this whole, Jupiter's losing energy at like whatever rate, and you just say, let's just say it had all that energy as thermal energy at the beginning of 4.5 billion or whatever years, it raises the temperature of Jupiter like a couple hundred degrees Kelvin or something, and then it's like, or a couple hundred Kelvin, sorry, and then it's just like, okay, so worst case scenario, we have a hot Jupiter.
Mm-hmm.
Oh no! The young Earth is proved because Jupiter might have been hot if we had an old universe. Like,
yeah, he doesn't pick Saturn as an example. I guess he figured that Saturn cooled off.
I think he might talk about the rings. Creationists like to talk about Saturn's rings.
Yeah. Well, okay.
So it doesn't take long. Well, now Jupiter is a much bigger potato, and so it can do that for much longer, but it can't do it for 4.5 billion years.
Why not?
It's not consistent with the secular age, but it's perfectly consistent with biblical creation. The problem is even worse for Neptune, which gives off 2.7 times as much energy.
Yeah, I mean, it's the same with all of these things, where it's like, and the other thing with Neptune is 2.7 times the energy of the sun is a much lower amount of energy than Jupiter's 2 times, because Neptune is very, very far away from the sun. Very little energy falls on it from the sun.
Yeah.
Energy as it receives from the sun. Now, how could that be if it's 4.5 billion years old? It should have run out a long time ago. I just want you to imagine what those would look like if they were billions of years old. They'd be icicles by now.
Unless they started out a little bit warmer. That's all it takes.
Yep.
Just start out slightly warmer and have nuclear decay processes keeping you warm. And then you can be warm for billions and billions of years. Because I assume he knows that many radiometric isotopes have half-lives in the billions of years.
And also to say that the indicate, for example, like with Io, we know that the thermal energy radiating from it, almost none of that, I mean, it's very, very tiny bit was from the energy of formation.
Right.
There are other current processes that, in the case of Io, tidal and coulombic, that cause it to be the way it is. Similarly, that there's processes going on in Neptune that cause it to radiate what it is, but it has certainly a certain amount of energy, and it's radiating for 6,000 years or 4.5 billion years. Right. It's not a problem.
And the thing is that he makes it sound like, Jupiter is radiating like just huge amounts of energy, but per square kilometer, not really in terms of thermal energy. Like if you look at Jupiter, it's not like it's incandescent, right?
No.
So
there's very little sunlight that the sun is actually relatively dim out at Neptune.
Right.
So it doesn't take much for Neptune to have an internal process to radiate more than it gets from the sun.
Yeah, basically, it has an internal process generating heat. Okay, there you go. It's probably going to be more than the sunlight.
And I think I would say that I think he knows that, but what he's trying to do is to make this assumption of, look how, quote, dumb these non-creationists are. They can't understand this thing trivial. So I'm going to give you something that'll fool you into thinking you're smarter than them. And you can then, when they give you something you don't understand, you just say, "What, they're dumb."
Yeah.
It's an intellectually dishonest thing that I suspect he's doing.
Okay. Well, here we go. Let's get a little more and see what else he's got.
They wouldn't have that internal heat. These are hot coals, as it were. I mean, they're not hot compared to what we think of, but they're hotter than they should be if the secular view were true.
I mean, show your numbers.
No.
The Earth has a magnetic field that's caused by electrical current in Earth's core. That's how you make a magnetic field. And that surrounds the Earth, and it actually protects us from cosmic radiation that streams from the sun and from other objects in space. So
I'll give him that one. That's right. We'll give him a drink.
All right.
That's broadly correct. And actually, it's close enough to, like, if I want to nitpick about, like, the Dynamo and like that would just be pedantic. It's fine.
I gotta give him that. I won't nitpick there.
Yeah.
So that magnetic field actually has a purpose, at least for the Earth it does. And of course, some other planets have it too. We don't know maybe what the purpose is for that, but it's certainly interesting.
Okay, so at first I was going to say, like, okay, it has a purpose. We'll just give that as, like, sort of a teleonomy kind of thing, where it's like, yeah, it serves a purpose from our perspective. But then when he's like, what's the purpose of electric fields on other planets? Then he's clearly being teleological at that point. And it's like, there isn't one.
Yep.
They just exist.
another thing again, and this is something where I think he gets wrong, and also some scientists gets wrong. What you should say is that if our current model of the origin of Earth's magnetic field is reasonably correct, one of the principal constituents is a dynamo that occurs in the boundary between the solid state and liquid state down near the core. But if you want to see faster, you say if our model for the Earth's magnetic field is really correct, it's primarily what we call a magnetic dynamo.
Right.
And but you need to say those things rather than to state facts, right? You do not say the
Godzilla.
Oh, there you go, Godzilla. There you go. You do not say this is truth unless you're a creationist or a biblical literalist.
Yeah. All right. Well, let's see if he's going to be even more teleological.
That magnetic field, because it's caused by electrical current, and current encounters resistance and decays with time, and so Earth's magnetic field is actually decaying, and we've been able to measure that over the centuries, and we know that Earth's magnetic field was much greater in the past than it is today. We've measured that over at least the last century and a half.
I'm not aware of any such measurements. Are you?
The magnetic field changes now. I don't know what this intensity here is. Is he suggesting that there was, during the flood, polar reversals?
Yes, it does seem like that.
Is he suggesting, because we do know from geologic record that the Earth's magnetic field has these polar reversal flips, and we know that it varies. We also know from observation that the apparent magnetic pole moves, and that it goes through variations. But this thing here, with this sort of this decay and this wobble back and forth, no.
And well, another thing that I want to point out is that so the reason that creationists like Lisle like to shove pole reversals that we know happen because we can see them in seafloor rock, right? They want to shove it into the flood because they think that the continents broke up from Pangea to their current position over the course of 1 year during Noah's flood.
That's a pretty good trick.
It's a pretty good trick in that it would vaporize the planet. Actually, it would ionize most of it because the amounts of energy required are astronomical. Doesn't cover it. We're talking about the Earth becomes a mini sun for a while. But no, absolutely impossible to survive even as a physical structure, the Earth, during that kind of an event. So it's just not a possibility. Actually, Landon, I don't know if you know who Erica Gutsick Gibbon is.
No, I don't. Sorry.
Okay, well, I'll send you a link to her channel later on. She has a video where she went through the math on these kinds of catastrophic plate tectonic ideas and gave the energy densities required. And I think you'll find it rather amusing, the kinds of absurd amounts of energy we're talking about.
Yeah.
And now we think that during the worldwide flood, because of the rapid plate tectonic movements and such, that would have disrupted that current and caused oscillations in the field, but that just drains it even faster. Aside from the flood, which most secularists don't believe in a worldwide flood anyway, so from their point of view,
for good reason,
continue going as you go back in time. It would just go up and 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 up.
No one thinks that. No one thinks that. There is no evidence of a steady decaying in the strength of the magnetic field. There just isn't.
Yeah.
All we have is it varies in strength up and down a little bit, and every once in a while it reverses its polarity.
Yeah.
That is it. Sorry.
And as planets evolve and they become geologically less active, then their magnetic field structure transforms. Right. So you get something like Mars, you just get a bunch of quasi-poles and a fairly weak magnetic field.
Right. That will eventually happen to Earth, but the thing is that Earth is still generating more heat than it needs to keep this going. We're at more the mantle and the core. Sure, the surface might be heating up, right, with global warming. That's one thing. But when you talk about the actual core and the mantle, they're at more or less steady state right now between like radioactive decay and tidal forces and heat lost just to radiation.
And if our model for the formation of the universe, the formation of the Earth is really correct, the reason why Earth is much more geologically active than you would expect it to be is because early on after its formation, it was impacted by a very large object, probably Mars in size, and the resulting collision vaporized much of the material, and a lot of the heavy, dense elements sunk to the vapor center, which helped form not only our nice solid core, but also the reactive materials there created a dense heat locale from their decay that causes the Earth to be even much more geologically active than you would otherwise expect.
Yeah. All right, let's see what else we got.
6,000 years ago, pretty strong. But you go back a million years, that's an exponential growth if you go back in time. If you go back millions of years, the magnetic field would be so strong it'd rip the iron out of your blood. That's not good.
You make the assumption there is an exponential decay.
Right. Well, and the other thing is,
and there's nothing that's going to reverse the process, right? You should know as an astrophysicist the mechanisms to create magnetic fields.
Right.
And you should know that those mechanisms are not constant, and it's not a matter of it locks in and then all magnets decay over time.
Well, another thing that I'll point out is that humans can survive just fine without the blood in their bodies being ripped out under extremely strong magnetic fields. If you might have ever had, say, a CT scan, you were exposed to magnetic fields that just absolutely,
like a Tesla, type of thing.
Yeah, like it absolutely dwarfs the Earth's magnetic field. Like there's a reason that you're not allowed to take any ferrous material in there. It's because it would be stuck to the machine with incredible force. So Jason,
it can't be that old. It just can't be. It would have been too strong initially. But it's not just the Earth. The other planets of the solar system have very strong magnetic fields, at least some of them do. Jupiter has an enormously powerful magnetic field. It's huge, it's strong.
For the same reason, it's also giving off more energy than it receives from the sun. Right.
Yes. And in fact, we know a lot more from the Juno probe about the composition of metallic hydrogen conditions. We presume it's metallic hydrogen. And the liquid helium and some of that other superfluid stuff, which generates enormous currents that are part of the Jupiter's fairly interesting magnetic field.
Right.
But why is it still so strong if it's billions of years old? It's consistent with thousands of years, but it's a problem for millions or billions of years, especially for billions of years.
No.
Yeah. The planet Uranus. The planet Uranus is actually tipped on its side, so it rotates this way. It rolls around the sun, kind of, which is interesting. It's interesting in and of itself because that really doesn't have a good.
Why do you have 59? Isn't it closer to 97? Or is
I'm not actually sure off the top of my head. Let's find out about that.
I'm not aware that Uranus.
So, yeah, 98 degrees.
Okay, off by 1 degree. Sorry.
Weird. Yeah,
I know that.
I don't know why he would have that. Yeah, that is bizarre.
I mean, the pole rotation thing has been known for quite some time, so I don't know why he's using some.
Yeah, that is bizarre. Is there any planet that has a 59? No. Nothing is even really very close. All right. Thanks, Jason Lisle, for not even putting up the bare right number that doesn't in any way contradict what you're saying anyway. So you could have just done it.
He's correct. It's rolling around, but his graph and diagram doesn't fit.
Yeah. Oh, I'm hitting play in the StreamYards window. That's not how it works. I have to hit play on the actual Chrome tab.
Interestingly. But it also has a fairly strong magnetic field. And the magnetic field, by the way, is tilted relative to the rotation axis. So the magnetic field would wobble as the planet rotates. Really strange. Really strange.
Oh.
It doesn't fit into the...
We had a quick question from, who was it? Verlian, who asks, what about the magnetic field around Sagittarius A star? I'm not aware of any significant magnetic field.
No, I'm not. I mean, the galaxy has an overall galactic field that the Voyager probe has actually confirmed, and we've done by indirect observations as well. But there's not really any sort of big, giant magnet at the end of at the middle of our galaxy. We have an overall structure, magnetic structure, but
yeah. Well, one thing
I'm not aware of any measurements that show. And in fact, given the radio measurements that we have around Sagittarius A star, if there was a strong magnetic field, we would see the influence of that on electrons in that area. We don't. So
yeah. Well, one thing I'll say is, as far as I know, the only way to get a magnetic field, there we go, around a black hole would basically be to drop charged particles in it to impart a net charge, which would then still be felt outside of the black hole. But the thing is that current thinking is that on net, black holes tend to be very close to electrically neutral, because as they gain charge, they attract things of the opposite charge, which will then fall in, canceling out whatever charge it is that they got. So the more electrons you throw into a black hole, the more it's going to attract protons.
Yeah. By the way, I think what he's doing here is N and his S are dealing with the magnetic field, the current magnetic field, not the physical spin. Because I believe the magnetic field is around 59, 60 degrees off of rotation. So I think what he's showing here in an S is dealing with the magnetic field. But again, it's also off axis as well. You notice it's not centered.
Is that accurate?
That is correct.
Oh,
that is correct. But one of the things in particular is that the observation shows that the southern hemisphere it's asymmetrical. So the southern hemisphere had a different magnetic field strength than the northern hemisphere, given the way that the lines go through.
Okay. Also, we had John Robb said, I think that both you, me, and Landon could do a retrofitting of science even better than this guy. Yeah, probably. If we wanted to make up our own young Earth creationism, we'd probably have a better run of it than Jason Lisle is.
Yeah.
But I could handle a lot of the squishy biological kind of things, and you could handle a lot of the crunchy, and I guess also like diffuse gaseous nebulae kind of things.
Yeah.
All right.
And everything else is just a mystery.
Right. Here we go.
Secular thinking at all. I often think that God made Uranus just to confuse the secularists, because it just doesn't fit into any of their schemes. I think that's its main purpose. In any case, its magnetic field is quite strong. Strong enough, in fact, that the planet Uranus has aurora, northern lights. In fact, that little white speck you see, that's an actual image of Uranus. I mean, we've imposed the lines on it, but the image is real. And that little white speck you see on the bottom, that's the northern lights. And it's 1 billion miles away from the sun, much further away than the Earth. And yet the radiation from the sun is still able to generate northern lights because the magnetic field is so strong. How about that? It can't be billions of years old.
It's not hugely strong. It's got, I think it's somewhere, the field varies between about 0.1 Gauss and about 0.23 Gauss, depending on whether you're northern or southern at the surface, right? It's not, but it does have, a dipole moment is about 50 times that of the Earth. So it's got a pretty good overall system. It's not huge in terms of universe, but it's a bit stronger than the Earth.
Okay.
The magnetic field would have run down by now. In fact, a colleague of mine, Dr. Russ Humphreys, who used to work for the Institute for Creation Research, he's retired now, he actually predicted the magnetic fields of the outer planets, especially of Neptune, before it was measured by the Voyager spacecraft. Isn't that interesting? See, the evolutionists thought that those magnetic fields would be very weak because the planets are billions of years old. But Dr. Humphreys said, well, no, based on biblical creation, 6,000 years ago, they ought to be about this strength. And he was exactly right.
Was there actually a prediction about particularly weak magnetic fields back before Voyager?
No, and again, this is notion that somehow magnetic fields are decay. You set them in motion and they just die away. Is not consistent with.
Yeah, that's. So I'm not actually too sure about the Humphreys prediction thing. I've seen some things that might make me think that maybe he did actually come up with something that was in the ballpark based on some assumption. But this characterization that scientists were expecting there to just be no magnetic field at all, I've never seen anything about that. So I just think it's made up. Oh, and Brian Stevens says, will he show the math? No. No, he absolutely will not show the math. No, because there is no math. But
see, that's how good science works. If you start from the presuppositions of God's word, you can make successful predictions about what you find in the universe, and it works.
That's not how science works.
No.
You don't presume truth. You go through a scientific method, right? In fact, it's very unscientific. What you're doing is we have truth, and then we'll just make everything fit it.
Right. And the thing is that creationism in general has an abysmal track record of making predictions at all, never mind accurate predictions.
Mm-hmm.
So I'm more familiar with it in terms of things like, biology and evolution and things.
Sure.
And it basically just doesn't have predictions. And what predictions it makes are pretty wrong. In fact, some of the best predictions that are, by best I mean some of the predictions that were actually predictions that they've made have basically all been falsified. Like, there's this guy, Nathaniel Jeanson, who tried to make predictions about human genome replacement, or was it? I can't remember the term. But basically, it's how fast per site on the genome per year mutations fix in various in each site, right? And this helps you determine how long it was between two populations and how long it was that their last or their most recent common ancestor lived, right? So if you get this rate, you basically just need to figure out how many differences there are between the two populations and do the algebra, and you get a number in years. And that's how many years ago it was, with, there's an error bar, obviously. But Jeanson predicted this substitution rate that just doesn't actually fit observed science.
Sure.
And the creationists are still touting it. They're like, he made a prediction. It's like, well, yeah, but it hasn't borne out, so what good is it? But anyway, we'll keep going with Jason Lisle.
Also, very just understand that this notion that there's this enormous amount of energy in this magnetic field that can only happen if it's 6,000 years old is just fallacious. I mean, the amount, the aurora are a fairly insignificant part of the energy in its planet's thermosphere. It's not a big thing on that thing. It is it certainly was, it certainly is there, but this notion that it somehow is decaying, because an example is, well, why does not Uranus have as big of a magnetic field as Jupiter? Well, you say, well, it's smaller. Well, if you reduce it in size, it still has because it has very different physical conditions in the interior of Uranus than in Jupiter.
Right.
And those conditions vary. So the magnetic field can vary, and its orientation can vary, right?
And I want to point out, Robert Adsit has pointed out that when Humphreys made this prediction, he didn't just make the prediction based on some assumed decay rate and then 6,000 years. He assumed that the transmutation of water into primarily hydrogen and helium by some miraculous alchemical means would be producing this initial magnetic field. Because he thought that God made the entire solar system out of water that he transmuted into some other substances.
Oh, isn't that precious?
Yeah. Why he made that assumption, not a clue.
The secular predictions are almost always wrong. Occasionally they'll get something right, but even a blind squirrel gets a nut every now and then, right? But God's word consistently makes consistent and correct predictions, no doubt about that. Now, they've come up with an explanation. They've said, well, there must be some kind of recharging mechanism to recharge those magnetic fields, because my secular colleagues know they decay. Well, there's this magnetic dynamo that recharges them, kind of like the alternator in your car, which is a pretty sophisticated machine, and we don't find that in planets, by the way. But one of the predictions of that...
We don't find dynamos, Landon. You were wrong. There is no dynamo.
I think he's saying we don't find alternators inside.
Oh. Huh. But what about...
I think he was trying to make a joke, but he was also trying to make a joke to again try and fool people that are not educated, that you could laugh at people that don't share your creationist beliefs and you can treat them as stupid because I said so, right? He said, I claim to be a smart person, this is Jason, can tell you, people who don't understand, something that's misleading so that you can then presume that people who aren't creationists are stupid.
Yeah.
So that when they try to explain something to you, you say, yeah, but you're just stupid and you're going to hell.
Yes. If you don't believe in a young Earth and apparently water turning into helium, you are definitely going to hell. That is how it works.
Yeah.
Of that magnetic dynamo model, and one of its requirements is that the magnetic field be aligned with the rotation axis.
No.
Is it?
No, it's not. Are there any magnetic fields in the solar system that are aligned with the rotational axis?
No, in fact, you would find it very surprising if it remains aligned. The fact that it's off is part of the process of showing these sort of magnetic field drifts, and the dynamo systems and the chaotic nature of turbulence down in those boundaries is one of the reasons why you cannot expect it to be consistent. And we know from a direct observation that the Earth's magnetic field, the apparent poles, move and wander.
Yeah. It's actually been wandering pretty fast lately, hasn't it?
Yeah. And the wandering is not because there's any physical flipping around inside of the core. The wandering has to do with the processes that involve that align to different locations. So there's not a physical rolling of something. A magnetic field flip is not the world flipping over. It's the conditions that cause the orientation of the domains to produce an overall field that the domains can rotate on their own axis and change the orientation of the field and change the strength of the field. And in fact, as they become chaotic, the field decays, and as they become aligned, the field strengthens. And he should know this. Now, I suspect if you had a debate and you're talking about magnetic fields and their process and so forth, he would say yes. But I was trying to simplify it for the audience. No, what you're trying to do is to come off as a smart person, talking to people who don't understand, to tell them that people who don't believe your creationist myth are stupid. That's what you're doing.
I just want to point out, we've got let's see. We've got the North Magnetic Pole here listed, and so it's actually been getting closer to the North Pole, but it looks like in the next few years it's going to start going farther away again, just in the opposite direction. And so, yeah, I mean...
And it's quite likely, given if its current rate and acceleration of its parent position continues, that in our lifetime it will get actually quite close to, if not on the shore of Siberia.
Yeah. Well, in 1900, it was on land in Canada.
Yeah, and I think it was up until the 1930s, 1940s, and then of course you get the territorial waters, and then how much territorial waters Canada wants to claim. But it's now past the territorial waters, and it's now moving away from the geophysical North Pole and heading off towards Siberia on the other side.
Yeah.
Of the Arctic.
So, hey, Siberians, your compass might start pointing east or west depending on exactly where you are here in the next few years.
Yeah.
Oh, I always forget. There we go.
Yeah. So yes, the correction is that the pole has the speed of the apparent pole on the surface has been accelerating.
Yeah.
the same way. Neptune's magnetic field is tilted relative to its rotation axis substantially. So you see, it just doesn't work. But the creation model makes sense. Comets are made up of ice and dirt.
Remember in the pre-show what I said? I think he already talked about comets. That's because they always do. They always bring up comets.
They're icy dirt balls or dirty ice balls, however you want to look at it. And they orbit the sun in rather elliptical paths, going really far away from the sun, then they swing in close and they get slingshotted back out. Now, when they're far away from the sun, not a problem. When they come close to the sun, icy material close to the sun, that can't be good. It's not. And so what it does is it causes the comet to disintegrate. That's what a comet's tail is.
I would say I'm not. I mean, I realize he's trying to make a joke of good bad, but it's not good bad. It is right that comets outgas, and as they get closer to the sun, their outgassing.
Wait, that was a joke.
Increases. I think he's trying to make. Oh, that can't be good because you're a comet and you're getting close to the sun and you're melting. I think he's trying to make a joke.
Oh, I think we should drink for it.
Okay.
I didn't even notice that was supposed to be like a joke. Oh my goodness! And
it didn't go very well over at his audience.
Yeah, even they were like, "Okay."
But so he put up this thing that said can't last over 100,000 years.
Do we have?
That's not true.
No.
I mean, first of all, the duration of a comet as a structure, as opposed to a vapor cloud and a dust lane, depends upon a number of factors. It depends upon the amount of solar energy it gets from the sun, where the temperatures reach the volatility point of materials on the surface, its size, its albedo, its reflectivity. And so, for example, that they'll talk about, oh, this is going to be a great comet, and then it becomes a dud. Like Comet Atlas, we thought was going to be one of the fragments of a really great comet family, and it was, but it turned out not to be very interesting. In fact, the comet fragmented and didn't put on much of a show. Sad to say, because we thought it might have a good condition. The length of time that a comet can be a solid structure is fundamentally a position of how often and how close it goes to the sun.
Yeah.
So a very, very large comet that impacts the surface, that's the end of it, right?
Right.
As a solid body. Comets like Halley's that have a sub-century orbit will decay faster than something like, for example, let's say Comet Hale-Bopp that has tens of thousands of years. Comets that have 10,000 years or millions of years in their orbit will last a lot longer, right? And it also depends upon how often does their orbit change, because planets like Jupiter and Saturn, there's a Neptune, that have larger mass can tug on those comets and shift their orbits. So it might have, and that's sort of how this transfer process. You have things out in like the Kuiper Belt that have that are relatively long period of comets. It passes by one of the outer planets that has some mass, and it causes its orbit in certain cases to shorten. So when you get a comet that's has an orbit of a century or even a handful of years, it goes near the sun, you'll get multiple passes and it will vaporize much faster. So this notion that they can't last more than 100,000 years is sloppy science or a strange comment.
Well, let me play devil's advocate and say some of the ones that we currently observe couldn't have lasted 100,000 years.
True, in their current orbital condition.
Right.
But then you can get situations where the outer planets don't always tug them to inner orbits. They can also toss them out, right? They can even inject it from the solar system.
Right.
The inner planets can do it as well, but they're not as massive, and so they don't have as much of an influence as like Jupiter, Saturn, Uranus.
I think the argument he's going to make is the comets that we observe as that are going close to the sun could not have been primordial to the solar system if the solar system is 4.5 billion years old. I think that's the argument.
But if you got a short period comet, it's not going to last for a long time. Got a long period comet, it will.
Yeah.
Unless, of course, it has a really unfortunate close pass using his. That would be.
So, are you saying
bad.
that long period comets can become short period comets due to gravitational interaction?
And short period comets can become long period comets due to gravitational interaction.
Interesting. Let's see what he has for us.
Disintegrating. It's material being vaporized from the surface, blasted out into space. And that's why a comet's tail always points away from the sun, regardless of the direction the comet is moving. And so if you've seen a comet, you've seen evidence with your own eyes that the solar system is thousands of years old. It can't be millions or billions. We estimate a typical comet can last no more than 100,000 years. And some of them are much shorter because some of them come closer to the sun. I used the SOHO spacecraft in my doctoral work at the University of Colorado. And that spacecraft, all it does is look at the sun. And it's discovered many comets, because comets get very bright when they get close to the sun, because the material gets blasted away at an enormous rate. And that's hard for us to see. We can't look at the sun, but SOHO's designed to look at the sun. And so it's discovered over 1,000 comets.
Oh, Godzilla.
And I've seen video from the SOHO spacecraft of a comet going behind the sun, and that's it. I've seen comets destroyed in one pass. They do not last millions of years.
But there are comets that have periods on the order of hundreds of millions of years, and they will last. They can last a very long time. And in fact, now everything is like, well, when the sun goes into its giant phase, what will happen? But there are comets out in the Oort cloud that don't even get anywhere close to the sun.
Right.
That are going to outlast the sun's giant phase. Yeah.
Well, creationists like to just pretend that the Oort cloud and the Kuiper belt don't exist.
Yeah.
That's their trick there. They're just like, it's fake. Like, okay. Sure.
Find comets out in space. It's kind of like if you walked into this sauna where it's really hot and you see a bunch of ice cream cones there melting. You know they haven't been there very long.
Oh, and Brilliant says that, I've heard about this, but there was an article claiming that 70,000 years ago, there could have been a dislodgement of comets and asteroids from the Oort cloud caused by a dwarf star interacting gravitationally with the outer solar system.
Well, we know of stars that come in close. In fact, there was a if I can give you a reference, but there are stars that have passed quite close. And we have one that's going to pass within a light year or less.
Oh, when will that be? Tuesday? Few million years.
I mean, it happens over time. But if you look at if you look at stars in terms of but let's go forward and I'll get you the information.
Comets are sort of the ice cream cones of the solar system. Okay, we know they haven't been there very long. Compelling evidence for thousands of years. And
for thousands of years for those comets. I will give you that, Lisle. There is compelling evidence that the current short period comets probably haven't been there for billions of years. Fair enough.
A particular colleague said, well, there must be a comet generator that makes new ones, which they call the Oort cloud, basically. This is the view. But we haven't any evidence of an Oort cloud.
It's more of a reservoir than a generator?
Yes, we do have evidence. We see objects coming from there, and we've actually studied those things. Particularly, it's nice when one of those deep comets comes into our thing, because we get to see stuff in its primordial sense.
Yeah.
And again, the talk about in terms of stars that that pass close. There are stars that do come close to our star. And one of the things that we're getting with Gaia is a much more better measurements about star motions, but that's for a different.
Okay.
As far as we know, it exists only in the minds of the secularists. Spiral galaxies are another evidence of a young universe. Spiral galaxies, not all galaxies are spirals, but many of them are, and they rotate differentially, meaning the inner portions rotate quick, the outer portions rotate slower. And if you think about that, it would have to twist it up, wouldn't it? If the inner portions are rotating faster than the outer portions, that spiral structure would become tighter and tighter and tighter.
Why not?
No, that's further. It's a bar. Typically, the spirals have a bar in the center, and that you've got spiral arms that come out of that, and also the fact you have out much farther is you have dark matter that's dominating the spin as well.
Yeah. Well, and another thing that I like to point out is, and correct me if I'm wrong on this, but the structure that we're actually seeing as the spiral is not made up of a set group of stars. It's actually more of a density wave that travels through, or that, from the perspective of the stars, they are traveling through it. Am I?
Yeah.
Yeah. So
Yeah.
it's the spirals themselves do not rotate with the stars because they are a transient phenomenon, not a collection of set objects. So yeah. Lisle is incorrect. Oh yeah, and Robert Adson says, "Liar, liar, pants fire." Yes.
And once you get to something like 1 billion years, there wouldn't be any spiral left. It would be twisted so tight you wouldn't see it. You certainly wouldn't see wide open.
But that's not how. I mean, it's not like you have a ball of cotton candy that you're spinning around inside your cotton candy machine. That's not what's happening with galaxies, and I think you know that.
Oh, I'm sure that Jason Lisle does know that. As someone pointed out, do you know who Martimer is? He's a YouTuber. He's not terribly active now, but a few years back he was pretty active, and I don't remember what his job is, but he does a lot of stuff on astronomy. And he had a series on Jason Lisle where he called him Dr. Liar, because in order to get his degree, he has to know he's lying about these things. Like, there's no way he managed to get a PhD in astrophysics without knowing the correct answer to these things, and why it is that spiral arms don't spool up with the rest of with the stars.
And spiral arms like we have in this galaxy. You say, well, 1 billion years is a long time, and it is, until you recognize that the secularists believe that galaxies are 10 billion years old, because that's what their Big Bang model requires. And so you see spiral galaxies like this are not a problem for thousands of years. In fact, in 6,000 years, they haven't rotated very much. This is pretty much the way this galaxy looked when it was created, apparently. But if it's billions of years old, that spiral structure would be gone. And we don't see spiral galaxies.
That's not true.
No, it's not. And yeah, for the reasons that we discussed. I will grant him, though, that if God just poofed a galaxy into existence with a spiral 6,000 years ago, that I guess it also still would look mostly like it does now. Fair enough, I guess. But
yeah,
that's just omphalism, basically.
So I also say that given's not too much on your whole talk about that Oort cloud and closest stars. In Wikipedia, if you look for list of nearest stars and brown dwarfs, there is a section 2 that's distant and future past encounters, and you'll see, like a graph over a period of like 100,000 years of stars that come close and leave, and you'll see like the minimum distance. There's a star that's going to go, at least 710 that's going to have 0.17 or 0.18 light years from our sun, and that's about 1.25 million years from now. So those are things that come close to the Oort cloud or are actually touching the outer edge of the cloud and cause rains of comets to come down in these whole periods of heavy bombardment.
So it was in 1.2 million years?
1.28.
Okay, everybody, in 1.28 million years, make sure you get a really sturdy umbrella for the rain of comets.
No. But, Schultz's star got 0.8 light years. And that's, that was like 78,000 years ago. So,
yeah, I'm sure that couldn't explain currently existing short period comets, though, right? Because that's inconvenient.
Yeah. But anyway, this notion of, it's not really worth talking because his notion of the galaxies are these little wind up toys that if you spin them too long, they just wind up in a ball. That's not how galaxies work.
No. And he knows it.
He should be able to do the measurements. We know the motions of going on there. And in fact, the opposite was the case. Prior to understanding dark matter, the issue was that galaxies are spinning too fast and should be flying apart.
Right. That was one of the things that led us
not collapsing, right? And so he's not even wrong on that point of view.
Twisted super tight. We just don't find that. They're all young, apparently. Not surprising from a scriptural standpoint. By the way, those spiral arms, you notice they have kind of a blue color to them? That's because they're made up primarily of blue stars. I mean, they have some red stars as well, but they have a lot of these blue stars. And blue stars cannot last billions of years.
Correct.
Right. Well, they can't last. Can blue stars last 1 billion years?
Yes, they can.
How long?
I mean, if you start off hot and then you go through your main sequence, so you can have it.
Well, I think
back when you switch on, and then you can go into your red. Well,
I think
your red phase.
I think he's meaning that during the main sequence, while they're still blue, they're not going to be in that state for billions of years.
No.
Well, I will say it is fair that we don't have any primordial blue stars in the universe.
True.
But the thing is, those density waves, the reason that we can see a lot of relatively young, because it's fair to say that in any given galaxy, the blue stars tend to be the youngest stars, right?
I mean, given the age, given that age since the Big Bang, the stars that are near primordial are going to be lower mass.
Right.
Right. That stars, even like our sun, will have gone into their dwarf phase.
Right.
From the epoch of the early stars, but the early stars are going to be bluer for a number of reasons, and as they age, they'll redden.
Right. But so what I'm trying to say is, like, okay, so let's say we take a snap, like that galaxy that we just saw, right, where there were a fair few blue stars. Those are going to likely be among the youngest, the most recently formed of the stars in the galaxy. But the reason that we tend to see them in these arms is because that's where star formation is happening. So where you have star formation happening is where you're most likely to find blue stars, because they die faster.
So you look at your HR diagrams, you'll see the matrix sequence stars will start off as O, and they will then move down into B, A, F, G, so forth, and so they will redden over their time.
So I don't see why it's problematic, but here we go.
And my secular colleagues will admit that. They would say, yep. And the reason for that is blue stars, even though they have a lot of fuel, they burn it very quickly. They're sort of the SUV of stars. They have a big tank.
Oh, that was a joke.
That was a joke. Because they're expending that energy so quickly. And they cannot last billions of years. Millions perhaps, but not even 100 million years, some of these hot blue stars.
Okay.
My secular colleagues will concede that. And they say, well, there must be some process making new ones.
There must be some process, like we've never seen the process in action. Like we don't currently see it in action in the Milky Way and in nearby galaxies.
And of course we do.
Right. That's the thing. I've made this analogy before. This is like going out into a redwood forest and seeing the trees shedding seeds, seeing saplings, seeing relatively small redwoods, but then saying, well, I've never seen a seed grow all the way from a seed into a giant, 300-foot tall tree, so I don't think it happens.
Yeah, but we see stars being formed. We see protostars, and we see those, and we've even seen some of those. We've seen a couple of those protostars things open up, and the star brighten because of its shell is being expanded from its light push. So
yeah,
but they start off typically in a hotter blue state, and go into the main sequence, and then go into the red phase, and or drift into white dwarf, or some combination of the two, depending on their size and mass and conditions.
All right, here we go.
Guess how many new blue stars we've seen form? 0. Now you might read, oh, this is a star forming region. You might have read that in some textbooks.
Yeah,
but let me
I
explain
might
that
have.
to you. It's not because they see stars forming there. What they see are lots of blue stars there. They say, well, there must be stars forming there.
No, we actually see protostars. And we see collapsing gas clouds that are getting closer to being a protostar.
Yeah, and we see things where the amount of nuclear fusion is rising because the cloud is collapsing and beginning to generate fusion.
And the thing is, like I keep pointing out, Dr. Lisle has a PhD in astrophysics from an accredited university. He knows that he is lying here, because he could not have acquired that degree without knowing that he is incorrect about these things.
Or he's chosen to reject it. He was dishonest then and said, as a student, I'll give you my answer so I can get my degree, and now I will disbelieve it. He may have he may be a candidate for some of those people that committed intellectual suicide.
I mean,
as opposed to people that are just remaining ignorant.
Yeah, I guess he could at this point just be delusional, but he was either lying then or lying now. So,
or because we know those can't have been there very long. You see how they think about these things? It's all about your presuppositions, isn't it? But we do not find anywhere in the universe gas actually collapsing into a star. No one has ever seen that.
Except where we have.
Yes,
They tell you that.
We see that often. Particularly, that's one of the reasons why they bring in infrared astronomy, because the clouds tend to be fairly opaque, but at the infrared we can see the heat and we can see the process of collapsing. And we've actually seen a couple of those actually open up.
Yeah. So, wrong again there, Dr. Lisle.
Yeah.
So the Bible, the age of the universe is confirmed.
Actually, we are at 55 minutes in. So, oddly enough, I thought that we were going to get to the two-way light speed craziness, but you know what? We got to go over a lot of astronomy, like how we know where comets come from, how we know where stellar regions are. So that's one of the things I like about these is we can use this craziness as a platform to talk about actual science, like how do we identify star-forming regions? What are spiral arms? Stuff like that. So,
and I have to say that my opinion of Dr. Lisle is because, again, this is my first experience to seeing his stuff. And part one, he was doing Glory of God. I was saying, okay, you're doing this sort of presuppositionalist big universe stuff. Basics, you got a lot of stuff wrong in terms of things like magnetic fields, comets, galaxy windups, lack of seeing stars evolving. And I got to sit there and say, well, what is he doing? Is he somewhere between being ignorant or intellectually dishonest or deceiving? Has he, for example, taken his education, made a assumption he's going to throw out everything that doesn't fit his literal narrative? Because he was, under basics, taking words and saying, see the Bible, I'm going to interpret the Bible and interpret its poetry and give it poetic license to fit something to say, see, it's scientific correct. And then he goes around and says, this is literally true. It has to be, otherwise I'm going to hell or whatever. And therefore I'm going to now commit these fallacies, right? If he was here, and I would say, but that's not true.
Yeah.
I know that's not true. I know that, and in fact, what you're doing, this little rhetoric thing, is you're trying to preach to your choir in front of you, these people in this seminar, and you're trying to give them a attitude. The attitude is, I'm going to show myself to be allegedly a smart person. I'm going to give you ways to ridicule people that are giving you information that you don't know how to defend yourself against by just saying you're stupid. And therefore, if they come up with something really smart, then you could just say, but you're dumb and you're going to hell. So, dismiss it. That's kind of the dishonesty that's there. And again, like with that business of the magnetic field decay or the comet stuff, if it was, I can't talk to him through the video, but if he was here, I would say, I am almost certain that's not true.
Yeah. Yeah. Well,
and it speaks to your character, right?
Oh,
you claiming to be this literal God-fearing, Bible-thumping Christian are being not only intellectually dishonest, but you have the appearance of lying.
Yeah.
And so I don't think much. Kent Hovind is has the mode of a charlatan and a troll. And so if he says something crazy, I say it's part of his shtick. This guy should have known better, and has said a number of things that I think are dishonest. And I think I think you could say this impugns his reputation and impugns his character. I've been very disappointed with the stuff he's pulled out of his.
Yeah, well, unfortunately, welcome to the world of creationist astronomy.
Yeah.
Also, we have a $2 redo, a super chat from John Rapp, who says, "What does this button do?" And what that button does is it gets you to tell me what to say. So there you go.
Well, thank you very much for pressing that button and being experimental. Right?
Yes.
Science is all about experimenting. So more people try to do that. And by the way, another button you can press is that little thumbs up button.
Yes. Yep.
If you do that like button, you can experiment with that. Another good experiment is sharing. Right? You could share this with your landlord, with your ex-girlfriend or ex-boyfriend or ex-friend. You can send it to your neighbors, other things. You can experiment seeing how people react when you share this video with other people.
All right, well, I'm going to give some quick channel news, and then I think we're going to wrap it up. So let's see. Thursday will be the next speculative evolution video. I have a tiny little bit of audio recording left to do, and then make the thumbnail, and then that's basically it. That video is done and ready to render out. So it'll probably be uploaded tomorrow and be out the next day. Then this Saturday, I'm probably not going to have a stream. Right now, I just have a quick little video that I made as a challenge for Kent Hovind and his followers. There's little 5 questions. They're simple questions. Just answer them. And yeah, I don't think any of them will be able to successfully answer them, but hey, we'll see. Then next Tuesday will be Eric with Erica. And then the next Thursday after that will probably be another episode of Fluffy Dino Lads, although by then I'll have started probably working on the next things that aren't dinosaurs. And if I get it finished in time, that might end up being that week's episode. So yeah, and that's about as much about the channel as I can say for certain at this point. Thank you very much for coming, and Landon, I think at some point we're gonna have to schedule another one.
I think we have a possibility. Is there only 2 parts of his thing, or is there 3 parts?
There is a 3rd part. I don't know how far it goes. Oh, and hey, for $2 redos, John Rapp says, "I hit the thumbs up button a bunch of times." Good, right? Yes.
Excellent.
Yes. In fact, if you want to be thorough, what you got to do is you got to watch all my videos and give all of them a thumbs up. That's the real trick.
But in clicking that thumbs up button, you need to have an odd parity, because I believe it's a binary state. So as long as you click it an odd number of times,
right,
your experiment will have a value.
Yeah, make sure it's still blue.
So I suspect so he's gotten to this. We'll get some more of this. I guess he's finishing this age thing, right?
Yeah. Starlight is up there, so
I guess Earth and Starlight are the next 2 things in part 3.
Yeah, I think Starlight's the really good stuff though. But I also want to say so I have unlocked channel memberships. I am going to be working on some emojis, and then I will be putting up a poll as to how many people would be interested. And if I get enough interest, like if it's 1 or 2 people, I'm probably not going to bother. But if I get enough interest in putting on channel memberships, I will. And in case you don't know, those are a thing where you give a little bit of money to YouTube and you get access to custom emojis that I've made, and your name turns a different color. So it's similar to how my Patreon works. And I'm also going to allow you, if you're one of the members, send me an email or a message on Twitter or something, and let me know, and I can give you the link to the patron-only Discord server, because I'm going to have the same numbers as tiers. So there's going to be like I don't know if I'll do a $1 tier, but there'll be like a $5 and a $10 and a $20 tier, and you can get the same roles in that Discord server you normally would. You just got to send me something extra to let me know. But yeah, that's it. Landon, any last final words?
Oh, I guess a couple of things. Please check out Milwaukee Atheists. They do a lot of very interesting things in examining the Bible, examining things like the Apocrypha, and other sort of projects they do of sort of scholarship in religious studies. I would recommend. I would also say, please keep asking questions, because fundamentalist science is about questions. So please keep asking questions. Try not to fixate and hyperventilate on news too much. I would recommend that you spend maybe 5 to 10 minutes a day to catch up on news and don't dwell on it, and then turn off those 3-letter cycling things that get, and then spend more time being, interested in, for example, the latest, space probe that was happening and discoveries going on in the universe. There's a lot of amazing stuff happening. Not those other things aren't important themselves, but have a little bit of balance and a little bit of wonder. And I think you'll be more prone to mirth and laughter.
All right. Well, I think that's good advice. And I will see all of you guys again on Thursday for another Speculative Evolution Project stream. So thank you very much for stopping by, and I am out of here.